Welcome students. Now in this video we are going to talk about the tool materials. So before going into the details about the various types of tools or tool material, let us first discuss the very important properties for these tool material. So we are going to see now the tool materials. In that, first of all, we will discuss the very important properties for the tool material. Okay, so the very first property, very important property, that the tool material must be 35% to 50% harder than the workpiece material, isn't it? So very important. So the tool material must be 35 to 50% harder than the workpiece material. That is the very first property. The second important thing is that the tool material or the tool must absorb the shocks. Okay, or rather I can say that the tool material should be able to withstand with the impact loads. Its load carrying capacity should be very high. So the tool material has good toughness, that is its ability to withstand with the impact loads. So the tool materials must be absorb the shocks. This is the second property. Third, we can have the tool material should have less wear and tear. Yes, the tool material should wear very less. There should be very less wear and tear, so that we can get enough or a good tool life. So the tool material should have the very less wear and tear. Fourth, the coefficient of friction. The coefficient of friction between tool and workpiece should be low. Yes, the coefficient of friction between the tool and the workpiece should be low. And the fifth, that the tool material have a good thermal conductivity and specific heat. So yes, when the tool is having very good thermal conductivity, so whatever the heat is induced in the cutting zone, it will conducted by or carry away by the tool. Otherwise, if the heat is generated within the tool, so because of the higher heat generation, what will happen? The wear and tear of the tool takes place. Fast wear and tear will takes place. So that is the reason why the specific heat and thermal conductivity of the material should be high. So these are some important properties that the tool material should have, or indirectly the tool should have, isn't it? Now, which are the materials that we are using as a tool material in metal cutting operation? So let us start with that materials. So number one, we are having the high carbon steel tools. Okay, so high carbon steel tools, so the percentage of carbon is from 0.8% to 1.2% of carbon is there. Okay, then if you look at this, it is made by the forging operation. If you see the hot hardness temperature for this tool, HHT means hot hardness temperature, is 250 degrees centigrade, and on Rockwell C scale the hardness or the hardness of these high carbon steels are about 65 HRC. Hardness on Rockwell C scale. And the cutting speed which can be used for these high carbon steels is up to 5 meter per minute. And the best example you are having, the chisels are made by these high carbon steels. Okay, so in the high speed steels, this is also known as HSS tools. Okay, so in high carbon steels, if you look at the composition, very famous composition, 18:4:1. So what is 18? It is 18% tungsten, 4% chromium and 1%. Okay, so this is the high speed steels. Generally, if tungsten is present, then it is known as the T series HSS. Instead of tungsten, we can also use the molybdenum. So if instead of tungsten we are having the moly, then it is known as the M series HSS. Okay, so basic property what tungsten is going to give, that is high temperature strength, that is strength of the tool at elevated temperature, which will given by this tungsten. Of course, chromium is wear resisting, also the corrosion resistance, and vanadium along with this tungsten. Please remember, this tungsten along with the vanadium in this T series HSS, it is having excellent wear resistance. Okay, now if you look at the percentage of carbon here, so it is from 0.8 to 1% of carbon, and rest of the matrix is made up of iron, that is 76%. You can find here the ferrous, isn't it? So of course the ferrous is having the huge affinity towards the carbon. When you are using this tool with the ferrous materials, so what happened? So the carbon from the workpiece is going to diffuse and it will create some edge preparation on the tool, so the penetration of the tool into the workpiece is quite difficult. So that is the reason why it is not used with, this HSS tool is not used with the ferrous materials. Okay, if you look at the hot hardness temperature of this tool is 650 degrees centigrade, where at the cutting speed you can use up to 40 to 50 meter per minute. Okay, and yes, this is also made up by the forging operation. So this is the high speed steels, and please remember this very important composition. This is 18% tungsten or moly, 4% chromium and 1% vanadium. Okay, so this is about the high speed steel. Now the limitation of this is what? Ferrous materials cannot be machined, so for that we are having next development, that is the stellite. It is the trade for, this is the trade for the non-ferrous cast alloys, so it is made by the casting process basically, and its hot hardness temperature is around 800 degrees centigrade. Cutting speed and all is same as that of the HSS, that is 40 to 50 meter per minute. If you look at the composition for the stellite, so we are having the cobalt around 40 to 50%. Then chromium, if you see, it is from 27 to 30%. Tungsten, if you see, it is from 15 to 30%. And rest of the carbon you can have from 2 to 4%. Okay, so stellite is basically what? The replacement of the HSS for the ferrous materials, and it is made by the casting process. Almost same properties like that of high speed steels. Only see the hot hardness is quite more than the HSS. Okay, now the fourth tool we are having. So fourth tool we are having, these are the carbides. So if you talk about the carbides, so carbides having the major constituent element is what? The major constituent element is the tungsten. So it is that is the reason why this is also known as the tungsten carbide. Okay, or simply you can say the carbides or tungsten carbides. So the major constituent element is tungsten. So it is having the hot hardness temperature around 1000 degrees centigrade, and if you use the cutting speed up to 300 to 350 meter per minute. Okay, and this is made by powder metallurgy. But very important thing is that these carbide tools are not regrindable. They are not regrindable by the conventional processes. Conventional regrinding. So for this regrinding of these carbide tools, we are required electrochemical grinding process. That we are going to see in the non-traditional machining. So for just you can remember, the carbide tools can be regrinded by the electrochemical grinding process. And one very important thing is that we use the negative rake angle. We have used the negative rake angle in these tool materials. So see, this is the negative rake angle alpha. So this is why? Because carbides are very weak in tension, but they are very strong in compression. So we are having the negative rake angle with the carbide tools. Okay. So if you look at the types of carbides, so there are actually three types of carbides we are using. One is P-type carbide, second is K-type carbide, and third is M-type carbide. कौन से types है carbide के? P-type, the first type is P-type. What is P-type? So this is basically used for the ferrous materials. Okay, so these are used for the ferrous materials. For example, P10, P20, P30, P40, P50, like that. Okay, for the ferrous materials and steels, like that. Then we are having the next type, that is K-type carbides. K-type carbides, so these are basically used for the non-ferrous materials and also for cast irons. The non-ferrous materials and cast irons. So they are having K10, K20, 30, 40, K up to K50. And the third type carbide you are having, that is the M-type carbide. These are the general purpose carbide. These are general purpose carbides. They are having M10, M20, M30, M40 and M50. So these are the types of carbides we can use: P-type, K-type and M-type. Then what is the number actually indicates? What is this P10 and what is this P50? What is the aim behind that using these numbers? So actually see, when the high, harder and brittle the material, the low numbers are used. The low numbers, these carbides are used. Low number carbides are used. And for tough and ductile the material, we are using the high numbers. For tough material, we are using the large numbers or high numbers carbides. Okay, also for finish machining we are using these low numbers, and for rough machining we are using the high or large numbers. So see, this is about the carbides, the fourth tool material. After carbides we are having the ceramics. So ceramics, the major constituent element we are having, major constituent element is what? It is Al2O3, aluminum oxide, isn't it? And it is made up of powder metallurgy. Okay, the hot hardness temperature is around 1200 degrees centigrade, whereas you can have the cutting speed of that is from 400 meter per minute to 500 meter per minute. Okay, and which can be used for the continuous operations like turning. It can be used for continuous operation or continuous turning operation. Okay, and this is the tool which is having very low coefficient of friction, at tool and chip interface. Okay, so these are the ceramics. After ceramics we are having the cermets. Okay, so cermets are basically 90% ceramic plus 10% metals. Okay, so all the properties are same like that of the ceramics. Here only the hot hardness temperature is around 1150 degree centigrade. It is having the same properties, it is just the development on the ceramics, that is ceramics plus metals, you are getting the ceramics, ceramics plus metals. Okay, now after ceramics we are having the diamond. This is one of the hardest substance known to us, isn't it? The seventh is diamond. So what is the major constituent element for diamond? Major constituent element, yes, carbon. Is what? Carbon. It is made by powder metallurgy or graphitization, isn't it? So if you talk about the hot hardness temperature, it's 2000 degrees centigrade, and the cutting speed is also very huge, from 1500 meter per minute to 2000 meter per minute. And very important thing is, it is very costly. Too. Okay, so diamond, yes, of course this is the hardest element known to us, made up of the major constituent element is carbon, made by the powder metallurgy or graphitization, very high hot hardness temperature around 2000 degrees centigrade, cutting speed 1500 to 2000 meter per minute. The thing is that, as we discussed in the case of the diffusion wear, that is, if diamond में क्या है सबसे ज़्यादा? Carbon है, and when this diamond tool is used for the ferrous material, of course at higher temperature diffusion rate is higher, so the carbon will be diffused from the tool material. Okay, because in the workpiece there is iron, and iron is having huge affinity towards carbon, so all carbon will come out, and where it will be in between this workpiece and the tool, at the cutting edge of the tool, the diamond will the carbon is going to make some edge preparation. So that is the reason why the diamond tool is basically not used for the ferrous materials. Okay, so now which material is used? So the next development, only just replacement for the diamond in case of when the ferrous workpiece is there. So the eighth one is you are having the cubic boron nitride, cubic boron nitride, cubic boron nitride. That is CBN tools, very famous. So all the properties are same as that of the carbon, even the cost also almost same as that of the carbon. Only thing is that these cubic boron nitride tools can be used for the machining of, or especially as they are using for the machining of the ferrous materials. That is the thing. So this is the cubic boron nitride. All things are same as that of the diamond, even cost also. Only thing is that this can be used for ferrous materials. Okay, now the next development we are having, that is Yukon. Okay, so developed by the Union Carbide tool company. Yukon, this is the only tool. See, this is the tool which is rolled in the form of sheets. Very important, rolled in the form of sheets. So just like use and throw away type inserts, you are having the rhombus insert, you are having the triangular, rectangular. Okay, so whatever the kind of insert you want, whatever the shape, just you can cut by using a non-traditional machining process. Of course, maybe laser cutting you are having, electron beam you are having, EBM you are having. So using that you can able to cut the shape, whatever the shape you require for that insert, and you just use that and throw that insert. Okay, so throwaway type insert can be made from this sheet, okay, which is made by rolling operation. So Yukon is only tool. See, till now we have seen either forging operation or the powder metallurgy, but this Yukon is rolled in the form of sheet. Okay, of course the properties are superior to diamond and cubian, even cost also superior. It is again costlier than the diamond and CBN. So if you look at the composition for this Yukon, that is we are having columbium 50%, titanium 30%, and tungsten is around 20%. So this is the cubic, this is the after cubic, this is Yukon. And the last tool that we are going to discuss, that is the Cialon, which is the last. So the last tool now we are going to see is that the Cialon. So Cialon, which is again it is made by powder metallurgy, superior to the Yukon. Okay, and even cost is also more than this Yukon. It is very costly. Okay, now how it is made? So there is silicon nitride, then we are having alumina, yttrium oxide is there. So this is one of the hardest or toughest tool amongst all the tool we have seen. Also the cost is also very high. This is made by powder metallurgy. So what are the materials in the composition for the Cialon? It is having the silicon nitride, alumina and yttrium oxide. So see, you can see the name here, Cialon. So in this way, and of course if you look at the use of the Cialon, so this is very rarely used tool. This is very rarely used tool. It is generally used for the machining of It is generally used for the machining of the cast irons and sometimes the nickel based alloys or nickel alloys. So this is the information about CLO.